Hey class, this video is on graphing linear inequalities. So we've been talking about graphing inequalities and graphing systems of inequalities. A system of inequality is just where I give you two inequalities and you graph them on the same coordinate axis. All right, so what's going to happen is if you look over here, I'm going to give you two examples. These two inequalities are going to be for the first one. So for this first inequality, we have an inequality in slope-intercept form. We have 3, which looks like it's going to be our slope, and positive 4, which looks like it's going to be the y-intercept. So positive 4, meaning on the y-axis, we look over here. Positive 4 from the origin looks like it's right over here. And since our slope is positive 3, meaning I'm going to go up 3 and then over 1. So just so you can see that, our inequality for this first one, the graph looks like this, right? We have a y-intercept of positive 4. You're going to go up 3 and over 1, right? Because that's how you make 3 into a fraction, by putting over 1. Now, looking at this, I'm asking myself the question, why is it shaded like this? And why do I have this weird line over here? Well, if you look at the inequality symbol, it's less than. It doesn't have an equal to underneath, like this one over here. Now, since it doesn't have an equal to, it means it's going to be dashed. Okay, and since it's less than, that tells you where you're going to shade, right? If it's less than, think of someone that's like less than your height. Well, if they're less than your height, they're below you. So that's why of this line over here, we shaded below the line. All this stuff here is below. Okay, well, this other inequality that we have is y is greater than or equal to 1 over 2x minus 2, meaning my y-intercept is going to be negative 2. Looks like it's going to be right over here. And our slope is 1 over 2, meaning from this point, I'm going to go up 1 and positive 2 to the right, up 1, positive 2 to the right, just so we can see that our graph looks like this. So we have a line that looks like this. Now, it's shaded weird now. Over here, we look at the inequality symbol. It's greater than. Well, if someone is greater than your height, what that means is that they're above you. So of this line, I'm going to shade above everything. All these points satisfy this inequality. Okay, and also the equal to part of this inequality, if it's equal to, that means we are including the points on the line. So that means it's a solid line. Now the thing is, your answer for this, the solution, is where do the both shaded regions intersect? Where are they bounded by? Well, if I look at this pink reddish graph over here, it's all shaded over here, and the blue graph is shaded all over here. The solution is where they both intersect. So you want to look at this triangle right over here. So all this stuff that looks like a different color than blue and pink is your solution to this inequality. All right, so that's all you're gonna do. You're basically answering by coloring. That's all it is. All right, let me give you another example. I'm gonna put that away. I'm going to give you y is less than 2 over 3x plus 1. I'm just going to give it to you right there. It is a dashed line because it's less than, and we're shading below also because it's less than. All right, we have our slope, which is 2 over 3. So I'm going to rise 2 and run 3. And our y-intercept, where it crosses the y-axis, is at positive 1. All right, well, looking at this next one, I noticed something similar with this. They have the same they have the same slope, meaning that they're going to be parallel. But their y-intercepts are a little bit different, right? This is at 1, this is positive 6. So I'm going to give you that graph. All right, there it is. So we have dash because it's greater than, and we don't have an equal to, and it's greater than, so we shade above. Now, with this, in order for it to be a solution, it means that the shaded regions need to intersect. Now, they don't intersect, meaning that there's no coordinate, there's no points that satisfy both inequalities. So to this system of these two inequalities, it turns out that there is no solution. So there's no ordered pair that would satisfy either inequality. Okay, so for that, it's no solution. If you need any help, make sure you ask me, but that's the video. Hope you got a lot out of it. Bye.